Yeah, this is a component which we will work today, and we will work on using sheet metal cutouts on the band area. Okay, first our topic will be using cutout on the band area, because yesterday I have shown you that how to work. Okay, let's make a component first. Making a base tab. I'm assuming the dimensions. Okay, so I'm assuming is to be 4 or 5 inches. 4 inches I'm assuming. So it's approximately 100 mm. And this one, making this, okay. And length to be 5 inches. So approximately 125. And taking thickness to be, uh, I think, yeah, 2 mm is fine. Or we can also do 1.6 mm. K factor 0.5, because I want to use sheet metal, steel sheet metal for that. Okay, let me select the material as well. I'm just selecting steel SS304, and again we have to make a band at some angle. Taking edge flange, I'm selecting here. I think you can see my screen, right?
Yeah.
Okay. So I'm taking the angle to be 120-degree angles, and height approximately 5 inches. In product design, sometimes we may need to assume the dimensions, and later on we can finalize the dimensions. And for radius, because you can see here, larger radius has been used for visual purpose. So use default radius. I'm suppressing and using 10 mm radius, or maybe 6 mm radius. Okay, and the height already we have defined 5 inches, approximately 1 to 5. Okay, I'm doing that. So this, and now we have again a band on this side. It's now angle to be 135 approximately, or maybe 120. Length to be, and again using the radius to be similar way, 6 mm. And again is band, and angle again to be 60. Yeah. So sometime dimensions we have to, I'm just conceding the dimensions, and the radius I'm selecting here 2 mm. Okay, so something we have made like that. And now these corners are also, you can say, if I'm looking from sides, this is something like that, but we have made it look like that. Okay, we can change anything anytime. And for example, I want to make this angle to be 120. I want to make it 110. and also make it 110, and this angle to be 130. Okay, so till we arrive on the final design, we can adjust dimensions, modifications, anything we can do. So that is the process of part of the process of industrial product design. Let me save this component. Okay, now you have seen whenever we need to, the similar way we can use also go to features and we can use fillet as well on the sheet metal parts. For example, I want to use sheet fillet here. So okay, similarly we can all use fillets, and we can, you can say, make the corners rounds. Now we can make any cutout on these surfaces as we have discussed. If we want to, I want to make some cutout here, I can make easily. Okay, there is no issue. But if I want to make a cutout here, where this band area is here, the correct process to make a cutout on the band area. This is, band allowance. We call that the band allowance for the length, and this is the band arc actually. So here we cannot use extrude cut directly. Okay, sometime it may be feasible in the software, but while we will be manufacturing this component, there might be difficulty in manufacturing. Okay, so for example, I want to make a cutout here on this area. We have to use, uh, we have to use, go to sheet metal. There are feature unfold. Can you see?
Yeah.
Okay. I will select unfold from here and select fixed face. Which one is the fixed face for you? I can select this one as well, or this one. Collect all bands. State. You can see I have selected that face fixed while our fixed face was this. So you can see which band we have all the bands straight. Okay, like in a flat pattern, we have uh, unfolded all the bands, right? And now we want to make a cutout on this area, this band, right?
Right.
Okay, so for that we will use extrude cut here and selecting this surface and using, for example, I want to cut out a slot here on this feature. I want to use a cutout, some type of, you can say, slow type cutout. Okay, I'm not defining the dimensions because I don't need that actually. I'm just showing for demonstrations. So I'm just going to exit and again link to thickness and cutout. Okay, now we have made a cutout on the band area, and now again we have completed our task. Now we will need to fold it again. We have used the feature unfold to unfold the component, and now I will use fold, and it will select automatically the fixed face because it the software knows that you have used that face for unfolding. Now bands to fold, collect all bands and click OK. and you will see like that.
Okay.
So a band, this is a simple way, or this is the correct way to use cutout on the band area in sheet metal. Okay. Similar way, if we need a cutout here on this area, however, you can this cutout can be also, this cutout is not, you can say, affected by the band, but if it would have been a hole here, for example, we need a cutout in the middle, we can also make it a straight way, this cutout, but the best practice is to unfold that, or go to unfold here, and we need to make a cutout. Again, I will extrude cut, select surface, and I will use, you can say, center rectangle, or using okay, uh, relations. And again, I have taken 18 mm, and center is aligned here, and I'm just exit and link to thickness, and there is a cutout. Again, I just used the existing fold, unfold, fold, unfold. Getting my point?
Yeah.
Okay. So similar way, I can apply fillet. I'm taking radius 9 mm, because the length is 8 mm, 18 mm. So I'm taking
Uh-huh.
radius, and again selecting fillet. It is to be 3 mm, I think. So this way, we can make this simple bracket for holding mobile and sheet metal. Okay,
Mhm.
and concept clear to make cutout on the band area.
Yeah.
Okay, and there is a feature. Uh, Go to sheet metal. You have seen sheet metal. You can say some type of sheet metal. Yeah. While you have seen some sheet metal tray, uh, you have seen this type of feature. They are folding the, you can say, they are folding the edge, upper edge, so that for
Mhm.
safety purposes, so that it doesn't hurt. Okay, so that is called a ham feature. For example, this is not in this case. We don't need ham feature. Okay, let me make a new component like we did yesterday. I'm just not taking dimensions. Okay, and is now. For example, we have this type of sheet metal tray.
Mm-hmm.
Now, practically, if we go to one command is using corner. We have to use this closed corner. Okay, closed corner is when by default bending you will see like that.
Right.
Okay, these corners are, you can say, different. Either you have to weld,
Uh-huh.
or there is a option in sheet metal, we can close corner. This face is to extend. This face I want to extend, and it will automatically align other
Mm-hmm.
corner, and it will close that. And similar way, I'm selecting here and select OK. You will see we have just extended these corners.
See.
And this may be this blank portion may need to be filled with welding.
Mm-hmm.
So we use closed corner here, closed corner, or we may also show welded corner. You may use welding. Okay, you may show welding. Sometime it may be closed with welding. But that is a simple process to close these corners. Okay, totally we are welding on these corners so that they are closed and connected. Okay, there are two types of closed corners. So now, if we have welded corner, we cannot. Can you see? If we have
Oh, yeah, you
done the
can.
welding, we
Okay.
cannot flat pattern them. So I have to delete that or suppress that so that our flat pattern is working.
Okay.
And similar way, we are using a feature which is called hem. Hem is now if a component is like that sheet metal component, it may be sharp and hit us. So we are using this hem feature. I'm selecting this one,
Yeah.
and you can select control this distance. It may be 1 mm distance. So 1 mm is too less for the length, and here I'm selecting 1, and the gap may be 0.2. This may be 4 mm. Since the thickness is we have taken, I think, 2 mm.
Mm-hmm.
So this is for using, so that we are for the safety concerns, we are using hem features in sheet metal.
Right.
And also, if you want to use a component here, and similar way, suppose I want to use threads on this sheet metal component. For using threads here, we might use insert component. For example, uh, I'm making a component or something with having some threads in that. Suppose 20. I'm saving that component, boss. to window and phone, not phone bracket, part 3. Okay, so suppose we have made some cutout in that on this area.
Uh-huh.
Hole is 10 mm. Length to thickness, and just made a cutout. So assembly is different. If I want to use if show a feature in drawing or some component, so insert, go to insert and insert part. Okay, okay, insert part, and I'm selecting on the desktop. I have made a boss here. So just select here, and now it is done. Boss is, you can say, you can see this component here, and again now go to here and edit part. When it is you can say in other way, um, this is, we are inserting a solid component in a solid component itself. We are
Mhm.
inserting other component in a component. Not this is not assembly, but this is still part, and we are inserting other component in this assembly. Okay,
Okay.
so for that, when it will first of all, let me delete that. Again, I will go to insert part, selecting boss. Now there will be a dialog box is open on the left side, insert part. Okay, can you see?
Mhm.
Yeah. Now from that, what geometries, what reference, for example, I'm using planes. I want to import the planes as well, axis as well, surface bodies, whatever component, or you can say reference features is given, only those feature will be imported. Now we have option locate part. We have to precisely uh, place the component, so we need to locate part as well. When we have selected the locate part and we'll select OK, what will happen? It will open a new dialog box, locate part, similar like using mates. Okay, in assembly. Now you can see the planes are visible for this component. Okay, the boss. Now we have not made visible right plane of this main component, right plane of this part 3, and right plane of this boss.
Mhm.
We are making them aligned like in assembly. We are making them coincident. When they are selected, you have to select, you have to click add. Now you can see on the bottom side mates, similar way, not assembly, but still we are using mates. Okay, similar way, for example, I'm using this top surface to be uh, mating with this surface. Okay, so it's yeah, we have to delete the earlier one. First of all, I'm aligning this surface with this surface, and see, and add. And after that, I want to align this surface with the whole surface. Okay, selecting this, and similar way in assembly, this will be concentric. Add. Now, if we have used two constraint, if we want to use third constraint, what we have, I can plane, front plane of this one, and this vertical plane of this one. So add. Now the component is fully defined. Are you understanding what I'm doing?
Yeah, yeah,
Okay, inserting a part in a part itself,
yeah.
not making assembly.
Mhm.
So but before making, a flat pattern, we will need to suppress that. Okay, because with that we might not be able to, you can see, the component is
Okay,
missing
it's
now
gone.
because it
Okay.
has yeah, it will not show in flat pattern. So we can show number of component uh, on a sheet metal part, or it may be a machine part, or it may be a 3D model part as well. So this is using insert part. Mainly we use that in sheet metal for inserting, you can say, nut screws, etc. in these assemblies, and sometime maybe bosses like that as well, for providing some gaps for nut screw. Now there are configurations in the here. Can you see configuration manager?
Yeah.
Okay. In configuration manager, you will see a default part 3. We can also use uh, click, left click, then right click, and there is option add configuration. I can also add my own configuration. If I add flat, I want to make a configuration to be flat. Okay, select it, and you will see the name flat. Okay, one is default configuration, one is flat configuration. Now I go to flat configuration. Okay, and go to this feature manager design tree, and I can select from here. I suppress it here. Now it's not visible, and also I will unsuppress this. Okay, and again go to configuration manager, and I'm selecting this flat, sorry, default. So you can
Huh?
say I have made two configurations.
Oh,
Let me save this component. We have made two configurations. One configuration is uh, by default configuration, one is flat. When you will click on flat configuration, double click here, you will see the component to be like that.
mhm.
Do you understand what is the purpose?
Is it just for you to toggle back and forth to see, or can you does it
Yeah,
make a difference in drawing?
yeah. In drawing, we can use different configurations. If sometime maybe flat pattern may not be working while we are
Oh,
want to use flat pattern in drawing, sometime when a component is complicated, it may not work, it may fail,
right.
because so then we will use configurations. So we will
Okay.
make flat pattern configuration, you can say, separately here.
Mhm,
And also sometime other purpose are also there to use configurations.
mhm.
Okay, so similar way, I have made a, you can say, I have given a this component, this I think you can make this component from
Okay.
dimensions. Yeah, and again next practice is you have to make this assembly.
Right.
You will make these two component. You can take the height, widths, assume that as you wish, and
Sure.
hole sizes, dimensions, you can assume them, because okay, they are not given. Suppose they are not given,
Uh-huh.
you have to, and this you can say have, and this cutout as well. Okay, just for reference, after making two components, you have to assemble them, like we did in the assembly.
Right.
You will assemble them similar
Okay.
way, as we assemble in a simple assembly. Maybe we can assemble sheet metal component as well, aligning these holes with this hole, this hole with this hole, and this surface with this surface. Okay, and a similar way, middle plane of this, middle plane of this. Okay.
Sure.
If you have any difficulty or confusion, you can ask me.
Okay. Yeah, and so for the first practice,
First,
I don't see any for the first one.
just a minute. You mean this one?
Yeah, this one.
Yeah,
Sorry, the second one then, the one just below the second page. Yeah, this one.
yeah.
I don't see any radius callouts on this. So all the
Okay,
bends looks like they're
okay.
sharp.
Yeah, yeah, yeah. Actually, radius is not shown here. You can assume the radius when radius is not given. You can
Uh-huh.
assume radius to be inside radius to be equal to the thickness of the sheet metal. And
Okay.
how much thickness is given? Let me see. If thickness is not given, you can assume it 1 mm, 2 mm. And also,
Okay.
one thing I just forgot to tell you, we uh, we do not take sheet metal by the thickness value. There is a gauge table. We use gauge for sheet metal. When we go to the market, you will find you will find a when you go to the market and you want to buy sheet metal, you have to tell them the gauge value. For example, I'll tell you the 16 gauge. 16 gauge is approximately you can see just a minute, not clear. You can see just a minute. Can you see the gauge table? This is gauge number 7 and
Yeah.
16. It is 1.5, approximately 1.52, or some standard may vary. And if talking about inches, it will be 16 gauge. If you ask in the market and go, give me 16 gauge sheet metal, he will give you this one,
Mhm.
0.0598 inches, or in millimeter, it will be 1.5 thick. Similar
Okay.
way, you can say uh, 18 gauge, that is 1.2 thickness. Okay, and 20 gauge, it is zero point 0.9. Okay, 0.91. And 22 gauge, zero point 0.7. So on the upper side, the thickness will decrease. When you the gauge size will increase, it means thickness is on the lower side. And when the gauge number decreases, thickness increases. Okay.
Mhm.
Yeah. For example, and the 11 gauge is approximately 3 and in inches 0.1196. So you can say 0.12 inch.
Yeah.
So just check out this gauge table as well, so that you are aware about the standards used in the market for sheet metal.
Mhm.
Okay. And this component. You can assume the radius and the thickness for this component, just the dimensions you have to maintain. And try to make this assembly as well. This is a simple enclosure, and the dimensions you can vary,
Yeah.
because sometime in product design also we don't have dimensions. The customers only, client only provides us the hand sketches. He's giving the hand
Right.
sketches that draw something from that, and I have these hand sketches, so we have to assume dimensions as per the practical aspect,
Okay.
and we have to finalize them during the design process.
Mm-hmm.
Okay, and any questions on sheet metal for now?
Yeah. No, so far so good. Yeah. So it's just the from yesterday's practice, I'm just having trouble getting SolidWorks to show the bend lines. The bend notes are there, but it's just a line that's missing. I've tried a few different things, but none of them seem to work. So
Okay,
I tried toggling the sketch in the you can hide or show sketches. I tried that, and then in the drawing view, I also tried. So if you go to the I think what's it called? Um, the flat. I forgot what it's called, the flat thing, but you can see the flat view. You can show or hide that. I tried that as well. It doesn't seem to work.
okay, okay. Let's connect again after 2 minutes, and you can
Yeah,
share your
sure.
screen so that, yeah,
Yeah. Okay.
yeah, sure. Just after 2 minutes, I will connect. Okay,
Okay, sure. Sounds good. Yeah.
sure.